Hello, welcome to AP Daily. My name is Dan Bonarigo, and I teach at Riverside Brookfield High School in Riverside, Illinois, just outside of Chicago. All right, so this video is on topic 1.3, program design and development. In this video, we'll learn that computer programs are developed with a systematic approach to achieve a desired purpose. So specifically, what are we going to learn? Well, there are two learning objectives: to develop a program using a development process and to design a program and its user interface. All right. So the essential knowledge that we hope you to gain here are to understand a whole lot of things about the development process, about before we really start programming, and then talking about what we're doing while we're programming, and making sure that we understand some of the processes and procedures that need to be understood in order to develop a program. Um, some ways of preparing to program and making sure that we understand the problem that we're trying to address, and then how the different steps of the programming process are outlined. So let's look at some examples to really develop these essential knowledge statements. All right, so how is a program developed? Well, it all starts with an idea, right? So nobody sits down at a computer and just starts typing away and they come away with a program. They have an idea about what they want a program to do. So programs are developed with a specific purpose in mind. So when we think about developing a program, right, we always have the idea of what do we want this thing to accomplish. Developers follow specific steps and they stick to their plan. Now, sometimes the development is more exploratory than anything, and the steps are dictated by what happens, both good and bad. So when we think about early AI projects or artificial intelligence, we abbreviate that to AI. So let's think about like an early AI project, like a personal assistant, right? So a digital personal assistant is one where you can say, hey, set an alarm for 7:30 a.m., right? And then tomorrow morning your alarm goes off, right? Or, search the internet for this or play this song, you know. Um, so early on in this, right, developers were just trying to figure out like, hey, what is possible? What can we make a computer do that would resemble intelligence, right? Artificial intelligence, right? And so it was exploratory, right? They were just trying to figure out like, hey, what do you think we can actually accomplish, right? But once the early projects succeeded in developing some artificial intelligence, then the newer projects are like, okay, how can we actually use this, right? How can we make users find this to be useful in their everyday life? So developers start investigating the problem or the purpose, and then they reflect, right? So they start thinking about like, what are the different aspects of this problem or the purpose that I can attack here? So investigation is an important step in the process. So through investigation, developers must determine the requirements of the program. What do we want this thing to do? What do we want it to accomplish? We want to understand the constraints, right? What is not possible? What are we not going to try to do, right? So you think about like a digital personal assistant that is in like a smart speaker, right? We understand that there's not going to be a screen on this thing. So that's going to, have an effect on what the user can actually do, right? Or there's not going to be buttons, right? So everything has to be by voice command. Or, let's just say like a company says, hey, we want to release this in 6 months. So now the constraint is time, right? We don't have enough time to accomplish some of the things that we might think about, right? Or like, let's say that you are assigned a project in your class. Your teacher says, hey, this is due next Friday, right? One of the constraints is time. You don't have enough time to write this grand thing, right? You have to be very limited and very targeted about what you would accomplish, right? So understanding the constraints are a very important part of the investigative process. All right. Understanding the user concerns and interests. What is the user going to be concerned about? Or, what are they going to be interested in using this device to do? So how do developers investigate? Well, they're going to do a variety of different things. They might do surveys, They might do user testing, they might do interviews, they might do direct observations. So all of these kind of are very similar, but they're a little bit different, right? A survey, they might just have, a list of questions that they send out to people, right? Multiple choice or short answer, something like that, right? User testing, they might just send a prototype or something to somebody and say, hey, just use this, right? And then they log what the user does. Interviews, they might actually ask questions, but then they can engage in kind of a conversation to dig deeper into what the user might be concerned about or what they want to use it for or whatever. And direct observations, they might just say, hey, sit in this room and use this thing, and we're just going to kind of watch to figure out how you're interacting with it. All right. Now, after the initial investigation and reflection, developers design the program, right? So how are they going to design the program? Well, they're going to brainstorm, right? They're going to draw on investigation, right? They're going to say, well, these are all the things that we figured out. And so now this is going to help us to talk about what things we can do. We're going to storyboard, right? We're going to write out, or we're going to draw pictures about kind of what the user is going to do to show what is possible with our program. We're going to plan the user experience, right? We're going to say, okay, this is, how the user is going to have to interact with it. This is the output that the user is going to see, the things that they're going to hear, all of these things. All right. Then they're going to lay out the user interface, right? Like, what is the user actually going to have to do to interact with the device? Right. So is there going to be a screen? Are they going to have to click certain places? Or if it's, like the smart speaker idea, like what are they going to have to say? Right? How are they going to accomplish certain tasks? All right. And then they're going to organize it into modules, different components of the program that are going to be developed individually. And so they can say, okay, this group of people is going to do this group of people is going to do this, and this group of people is going to do this. All right. Then they're going to develop a testing strategy. How are they going to know that the thing that the device or the program is actually doing what they set out to do? All right, so developers are then going to decide on program requirements, right? So they're going to decide on program requirements that describe how a program should behave. They're going to include a list of the user interactions. So they're going to say, okay, these are all of the things that the program does, and then these are the list of the users' interactions, right? So that the users know what they can actually do with this device or this program. All right, the program specifications are going to outline all of the requirements. And developers are going to create a prototype of the program or the components, right? And this prototype or the components prototypes are going to be part of this incremental process, right? Now, the incremental process is frequently used so developers can refine small parts or modules of the program, right? And so they can test little small parts to make sure they're working before they put them all together. Then there's testing, and more testing, right? So like I said a few minutes ago, developers are going to test the program every step of the way. They're going to test at the micro level and then the macro level. So the micro level means these individual components, making sure that each of these things is working as it is supposed to. And then on the macro level, right? So we're talking about the whole program. Do all of the individual components interact with each other as they're supposed to, right? And is the user able to interact with the device or the program as they were intended to? And then developers are going to refine, revise through testing, feedback, and reflection. So they've tested it. They receive feedback. Users say, "Hey, it doesn't do this, and I'd like it to do this," or something like that. And then reflection. The developers say, "Hey, maybe we should have done this. Maybe we could do this. Maybe this is an opportunity to do this." All right. So what should we take away as a result of this AP Daily video? We should be able to develop a program using a development process. We should be able to design a program and its user interface. And then we should understand these essential knowledge statements. Thank you for joining AP Daily.